Hi friends, I explained about the leaf springs and coil springs in the previous video. Now I am going to explain about the shock absorbers used in the suspension system. Friends, we are discussing about the dampening parts of the suspension system. We have covered about the coil springs and the leaf springs. The another dampening part, the critical and most important part is the shock absorber. This is the shock absorber. We have seen the leaf springs on coil springs. The job of this coil springs or the leaf springs is to absorb the shocks generated due to the uneven road surface, that is potholes, humps, bumps, etc., so that the chassis and the passengers traveling in the vehicle are protected. But the action from these springs will be very instantaneous, because any spring, when it is compressed, the energy is stored which is ready to release. So in fraction of second it is always available to release the energy. Because of that nature, still there will be vibrations in the vehicle which causes a kind of discomfort to the passengers traveling, as well as creating stresses in the metallic parts of the vehicle. So to avoid such instantaneous jump actions, a dampening device, additional dampening is required. That additional dampening device is the shock absorber. The shock absorber does the job of absorbing the vibrations or shocks generated through the springs. Okay, how they absorb, how they functions also we will see. They absorb the shocks or vibrations through hydraulic fluid media. The construction of a simple shock absorber looks like this. This is the tube to store the fluid, and also the gray color indicates the gas. There will be a piston here and there will be another piston here. This is the floating piston. This is the piston fixed to the rod, piston rod, and the mounting, for mounting purpose there will be bushings. Any vehicle, 99% of the vehicles which are connected with the leaf springs or the coil springs are fitted with compulsory with these shock absorbers. Together, the spring and shock absorber together does the job of the vibration dampening or absorbing the shocks. The another important job of the shock absorber is the shock absorber always ensures that the tire should have the proper grip with the road at all times. There are two types of shock absorbers we can see in the vehicles, the commonly used vehicles. Type 1 is called the monotube, means single tube shock absorber, which looks like this. The other type is called as the twin tube shock absorber. If you look into the construction of the monotube shock absorber, these two figures indicates both are the monotube shock absorbers only. The difference is the mounting. This is having the rubber mount which can be mounted to the frame. This is having a bushing which can be mounted through a pin. The part, you can see the construction of the shock absorber, monotube shock absorber, a container or a tube to hold the hydraulic fluid, and also the compressed nitrogen. Compressed nitrogen is used as a gas here because nitrogen is not flammable like oxygen. So oxygen is not supposed to use because it is flammable. This is nitrogen. Then there will be a piston. This is a pressure piston or floating piston with a seal. The purpose of seal to prevent the leakage of the gas from this chamber to this chamber and to prevent the leakage of the fluid from upper chamber to this one. And there will be one more piston connected to the piston rod. This is also having seal, and also this having Walls here it is here. Restricted ports or valves are provided to this piston. And this is connected to one end is connected to the suspension arms, moving or reciprocating arm. The other end is connected to a fixed item of the vehicle, either chassis or something. The other end is connected to the frame. Okay. This also same identical parts. So this is upper mount looks like this in this type. In this type, it is having a bush. How this shock absorber works? When a road passes through a bump or hump, the spring is compressed. The coil spring or the leaf spring is compressed. When the spring is compressed, that compression action makes this piston rod to move downwards inside the cylinder. When the piston rod is moving, the piston also moves here. So the oil is available in the upper chamber and as well as the lower chamber. When the piston is moved towards downside, it creates the pressure in the lower chamber. When it is created a pressure, because the fluid is not compressible, so what happens? Either the fluid has to flow wherever it is having the passages, or the pressure has to push on any movable object it is available here. This is not the movable object because it is a tube. So what happens? The pressure acting on this fluid makes some portion of the fluid to pass through this wall from lower chamber to the upper chamber. Simultaneously, some portion of the pressure acts on this piston, which makes this gas to compress further. Already it is compressed at certain pressure to the extent of holding this piston. So it further compresses the gas. So smoothly, whatever the shock is generated through the spring compression is absorbed by passing the fluid from one chamber to the other chamber with a restricted flow, simultaneously dissipating heat through this tube and also compressing this gas available here. And as discussed, the energy stored in any spring during compression is always ready to release. The moment it just comes out of the bump in a fraction of a second, the spring expands. The spring is expanded, the pressure is released on this piston. Even though pressure is released suddenly, but the piston will not move suddenly outside. What happens if it wants to move suddenly outside? The oil available in the upper chamber will not allow. So the oil slowly passes from upper chamber to the lower chamber through this restricted flow. As the pressure is released in this lower chamber, the pressure is released on this piston also. The compressed gas expands slowly. When the compressed gas expands slowly, the piston also moves upward slowly. The movement of piston to outwards so decreases the pressure in the lower chamber, allowing a portion of oil again coming back through this restricted ports. Like this, the slow and steady movement of this shock absorber, because of its construction with hydraulic fluid and gas, makes creates a kind of smoothness in absorbing the shocks generated through the uneven roads. This is the animation. Imagine this is a fluid chamber, this is the gas chamber, how it works. Now let us move to the shock absorber. The construction of twin tube shock absorber is also identical, function is also identical except some change in the design. You observe this twin tube shock absorber. Instead of having one tube to contain the fluid, It has two tubes. This is inner tube, this is outer tube. There is a chamber space is provided, circumference space is provided between the inner tube and outer the tube. So both the tubes, inner tube holds the fluid completely, whereas outer tube, a portion of the outer tube up to certain height holds the fluid, and beyond that it holds the nitrogen gas. A seal is provided to separate the nitrogen gas and the fluid. This is the piston rod. This is the piston, main piston. This is called the foot valve. It is not a floating item as we have seen in the case of the monotube shock absorber. This is the fixed one, but it will be having foot valve. What happens when the spring is compressed? The pressure acts on this piston rod, makes the piston rod to travel downwards. So when it is traveled downwards, the pressure is acted on this piston, which makes the fluid travel from lower chamber to the upper chamber through the restricted flow in this piston. Simultaneously, a portion of oil moving from lower chamber to the outer chamber, that is the space available in between the inner tube and outer tube. So a portion of oil go from lower chamber to outer chamber, a portion of oil travels through this foot valve through a restricted flow to the outer chamber. So oil is being displaced from lower chamber to two other chambers, upper chamber and lower chamber, in a slow and steady manner. Simultaneously, when the oil level is increased here, the pressure acts on the gas. As the gas is compressible, when the pressure is increased, the gas is compressed here, reducing the volume of the chamber. So when the volume is increased, volume of the fluid is increased here, the volume of the gas is naturally reduced. When the volume of the gas is naturally reduced, the pressure is built up in the gas chamber. The moment the spring bounces back, the piston tries to travel outside, but not as fast as the piston is bounced back, because it has to travel against the force of the fluid pressure is available here. When the piston start traveling outside, and the oil available in the upper chamber slowly passes to the lower chamber. We can see the lower chamber volume is increased when the piston started traveling outside from here. So it is increased here. Simultaneously, when the pressure is released in the gas chamber, okay, the released pressure acts from this gas chamber on this fluid chamber of outer space. The fluid also passes through this foot valve to the lower chamber. Overall, when you observe, when the spring suspension spring is compressed, when the piston is traveled downwards, the lower chamber volume is decreased and the piston tries to travel outside, the fluid volume in the lower chamber is increased. This is how the twin tube shock absorber functions. You can see the animation, you can clearly see the how it happens. When it is compressed, the oil is traveling from here lower to upper simultaneously, from lower to the outer space. See these arrows. Same way, the piston is being pushed out. The oil comes from upper to lower and from outer to lower. This unit is called the strut. It is a combination of the coil spring and as well as the shock absorber. This unit is mounted in almost all the front suspension of the passenger cars, but it's not used in the heavy duty trucks or heavy duty buses. This is mainly used in the passenger cars. We talked about the linkages, we talked about the dampening parts. Now just let us look this figure which is have the joints. The part connecting the linkages or the shock absorbers to each other or to the chassis of the vehicle or to the frame of the vehicle are called the linkages. Ball joints, here bushes, here also bushes. So here again joint what I have shown you. So here one more joint, here one more joint. So this can be bushes, this can be ball studs, this can be swiveling joints. Different types of the joints are used depending upon the design of the suspension system. Friends, go through these 3 pages of notes. If you have any query, you can always contact through the email. Kindly subscribe to my channel and also ask your friends to subscribe to my channel.